Hi, this is going to be a video walkthrough of the MRP redundancy protocol configuration in our HiOS switches. The configuration that I will be walking through is going to involve our RSP switches. I'm going to build a ring of 3 switches, all on a 10-10-10 network with a 24-bit subnet mask. And I'm going to configure the first switch with the MRP operation on, redundancy manager off, and I'm going to select the MRP ring ports to be ports 10 and 11. I've chosen 10 and 11 because the fiber optic ports in these switches are SFP, and I currently don't have any SFPs, so any port, copper and or fiber, can be made ring ports. And whether it is gigabit or 100 megabit is irrelevant. So I'm going to choose ports 10 and 11 just for consistency's sake, and 11 is always going to be the port that then connects to 10, again just for consistency's sake. I'm also then going to make this middle switch right here the redundancy manager. The redundancy manager is going to maintain and check for the integrity of the ring, and if there is a break in any of the ring segments, it is the switch that's then going to send out the MAC address table flush and relearn command to all of the switches. The other thing that I'm then going to do is I'm then also going to disable rapid spanning tree on ports 10 and 11, just so that I don't have the RSP BPDUs traversing the MRP ring as well. And last but not least, I'm going to do some basic housekeeping. I'm going to change the passwords, name some ports. I'm then also going to adjust some of the alarms and notifications, save the configuration to non-volatile memory so that all of the changes that I will have made will survive a power cycle. And last but not least, I'm then also going to back up the configurations. So that said, let's get started. So one of the first things that I need to do is I need to assign the switches an IP address. And the switches out of the box ship without an IP address. They are DHCP enabled. They also will work with BootP. But what I'm going to do is I'm going to utilize our app, which is called HiDiscovery, to find the switches. It sends out a broadcast, and regardless of the IP setting of those switches, it will find those switches. And with this I can then also signal the switches. So I'm going to select the first switch, I'm going to signal it, and I can see that from all the LEDs flashing back and forth that this is the first switch. So I'm going to call this first. This could also be called building 19. This could be called the uplift pump, or whatever you want to call it, as long as it is representative, or should be representative, of the purpose of this switch. I can then manually type in the IP address, or what I can do is, because I've utilized the save as default, I have saved the IP addressing scheme for the switches. I don't have a default gateway, there's no router in this network, and this being the first switch, I'm going to call this a .2. And voila, we have addressed this switch. I'm then going to select the next switch, and this is the middle switch, so we'll call this middle, and this is going to be a 10-10-10-3. And then last but not least, this switch here, signal it just to verify, and this is the we have the first, middle, and I guess we can call this third. Actually, let's call this the right switch, and this will be a 10-10-10. This is a 10-10-10-4. As you saw, I had a duplicate IP address that I'd given it. We're going to call the first one the left, just to be consistent. So we have our 3 switches. And just because I can find these switches does not necessarily mean that I can talk to them. So one of the things I'm going to do is I'm just going to do a quick ping just to check layers 1, 2, and 3 that I can be able to talk to these devices. Also, if for some reason you come up empty on a scan on these switches, do check to make sure that you have your local area, your LAN port selected, and that your LAN port has a static IP address and that it is connected to the switches before you launch HiDiscovery. The last thing you want to check is check your antivirus. Antivirus is known to block the communication to these. So with that, the next step that we're going to do is we're going to log into the first switch. Simply select the switch, click on www. You can also open up your web browser, simply type in the IP address into it. And let me make this a little bit more palatable. And I'm going to add the exception, confirm. So the admin password for all of our switches, the default, is private, and it's all lowercase. So you'll see that there are a variety of alarms and notifications. For device status, I have an alarm counter of 1, which is the power supply. I only have a single power supply currently connected to this. The switch has 2 power supply inputs. I can either add another power supply. I can also jumper the first power supply into the second power supply input and spoof it. Or what I'm going to do is I'm actually going to go into the management of the switch and turn off this notification later during my housekeeping. Then we have security status. The switch will by default look at a variety of best practices such as the default password, minimum password length, and so on and so forth. These can be tweaked. What I'm going to do is, it's not a best practice, but I'm going to turn off these just so that I don't have any alarms. Last but not least, what I'm going to do is I'm going to utilize this relay. So all of our switches have a relay output. The relay output is currently triggered as a result of the power supply loss or the absence of a power supply 2 on this. I can then also give this a location. This could be building 5, panel 2, door 1, and this is where that switch is then located. I can give it a contact name. Could be the integrator, could be the OT manager, or whoever else is responsible for it. I can then also send a alarm based upon temperature. So it's a poor man's temperature monitoring capability. The switch itself does not generate 70 degrees of heat, so if you were to set this at 65 as an example, it would allow you to then trigger an alarm based upon the temperature. So first thing that we're going to do though is we are going to go into the switching and layer 2 redundancy under MRP. What we're going to do is we're going to enable this, and I'm going to set the ring ports for ports 10 and 11. We're going to leave the ring manager off for this switch. We're going to hit set. And the next thing that we're going to do is we're going to go into spanning tree under port, and under port we're going to turn off spanning tree for ports 10 and 11 just so that we don't again have these BPDUs traversing the network. So you'll also see that there's a floppy disk that's flashing up here. This floppy disk is telling you that there are changes that have been made and they are currently residing in volatile memory. By clicking on this, it will then take you to the load save, where you can save the configuration of the switch from volatile memory into non-volatile memory. And I just realized that by me turning off spanning tree on those ports, because I have the ring configured as a or all of the switches configured in a ring, I now have a broadcast storm, which is why we have this happening. So what I'm going to do is I am going to break the ring. So I've just broken the ring, and we have communication that's been reestablished. And what I'm going to do is I'm going to go ahead and I'm going to save this configuration to the switch. So configuration has been saved, and you'll notice that there's a countdown timer here, and what I'm going to do is I'm actually going to leave this countdown timer here. This is the logout countdown timer. So all intents and purposes, this switch, aside from the housekeeping, is done. So again, what I've done is I've gone into MRP, I've enabled it, so the operation is on. I've defined my ring ports, ports 10 and 11. The ring manager is off. I've then gone into spanning tree under port. I've turned off spanning tree on ports 10 and 11. And because I had everything wired as a in a ring configuration, this then caused the BPDUs or caused a broadcast storm, hence which is why I lost communication. And because I then broke the ring, I then was able to restore communication to this switch, and we're now going to go ahead into the second switch. So this switch, we're going to log into this, add an exception, confirm, go in with the private, all lowercase again. And we're going to go to switching, close that, expand this, layer 2 redundancy for MRP. We're going to turn the operation on. We're going to choose ports 10 and we're going to choose ports 11. And in this switch, we're going to turn the redundancy manager on. So again, we had opted to select this switch to have the redundancy manager on. Which switch is rather irrelevant. On a large ring, you may want to have the redundancy manager not in between the heavy talkers on the network, just so that the number of switches that the traffic needs to traverse, or that the majority of the traffic needs to traverse, is the minimum number of switches that it needs to pass through. So again, operations on, ports 10 and 11. I have the ring manager enabled. Click on set. Next thing that we're going to do is we're going to disable the spanning tree protocol for those ring ports. I'm going to go into spanning tree port, and on ports 10 and 11 we're going to disable spanning tree, and we're going to go into the load save. We're going to go ahead and save this. So if for some reason I accidentally forget, at a minimum these changes will then be retained during a power cycle. So okay, and then we're going to go into the last switch. And in the last switch, log in as before. And here too, we're going to collapse this just to keep things nice and neat. Layer 2 redundancy, MRP. This one does not get the redundancy manager, so ports 10 and 11 enable. And then we have spanning tree, under spanning tree port, and we're going to turn off ports 10 and 11. So with this is pretty much the only thing that needs to be done. I'm going to close this ring now. And I'm going to go back to MRP, and I'm going to do a refresh. And when I do a refresh on this switch, it says redundancy available. The ports are forwarding on both ports, and this flashing floppy disk. Let me take care of that. And I'm going to go ahead and save. Then for this middle switch, I'm going to do a refresh. Redundancy available. this port is forwarding and this port is blocking. So what this port is doing is it's preventing the traffic from creating a loop, and it's doing its thing. So going into here, we can then do a refresh, redundancy available, forwarding. So I now know that the MRP protocol is doing its thing. Also, the switch that has been designated as the redundancy manager, the LED for the ring manager is lit green, so I know for a fact that it is operable. If I were to cause a break in the ring, which I just did, that LED will then go to amber. So all of the basics have been done. The next thing that I'm going to do is I'm going to start doing some of my housekeeping, and the housekeeping is going to include getting rid of some of these alarms and making them all more relevant. So I'm going to address the power supply. Let me close this, and what I'm going to do is I'm going to go into diagnostics and status configuration. Under this tab are 3 other tabs. These other tabs are directly related to this alarm right here. Security status is this, and the signal contact is this. So if I go to device status, you'll notice that there are a variety of things that the device status can monitor, one of which is power supply 2. So what I'm going to do is I'm going to turn this off, and I do want it to monitor both ring redundancy and connection errors. And connection errors is something that I can then define, and I can define that right here. So I can define not only my ring ports, but for example, if I had a PLC connected to port 4, I can then monitor that link as well. So in this case, just having the ability to monitor ring redundancy is all that I really need. I don't need to necessarily monitor the device status or the connection errors on the device status. So with that, I'm going to enable that. And if I now go to here and I do a refresh, you'll notice that the alarm counter has been turned off. Next, we're going to go to security status. In security status, the switch is monitoring a variety of factors. This can be custom configured per customer and the corporate standards. So in this case, I'm going to go ahead and I'm going to turn everything off, with the exception of, let's change the default settings at the very end. So I'm going to go ahead and write this, and if I now go to system and I do a refresh, instead of 8 I should only see 1 alarm, and this, if I hover over this, says that the password is still in a default state. And last but not least, under signal contact, this is one where I do want an output, and what I'm going to do is I'm going to disable the second power supply monitoring. I want to monitor ring redundancy, and in this case I also want to be able to trigger on any connection errors. So I'm going to enable that, and as soon as I clicked on this, I heard the relay of the switch open itself and indicate that that this is no longer in an alarm state. So the other thing that I'm then going to do is unfortunately this switch doesn't have any other devices connected to it, but what I can then do is I can then propagate on connection error on this switch, and as soon as I did that, I again heard the relay trigger. So because there's nothing currently connected on this port, is why the relay triggered. If I uncheck this, I again hear the relay trigger. Actually, in this case, it's the relay actually opens, and it's a great way of keeping tabs on the ports that that one has populated, just in case there is a loss of comms or someone disconnects that that cable. So right now it's just monitoring ring redundancy, and I'm monitoring temperature, connection errors. Let me go ahead and disable that. And I can also then monitor, the device status, security status. The device security status, monitoring correct mode. This is the default. So let me do a quick refresh. So this is the way that I would like to have the switch configured. Last but not least, I'm going to go ahead and save this. And I can then proceed to make this change with all of the other switches as well. Obviously then saving that configuration. The last thing that I then may want to do is I then may want to save or export that configuration. Oops. So we'll select this, and we're going to go ahead and export this. I can export it to a URL. The other thing that I can also do is I can then also save this as an alternate config. So if I'm about to start tinkering with this switch, what I can then do is, if I know that this is a functional configuration, I can then call it functional. I can then save this, and what I can then do is I can then start tinkering with an alternate configuration. So what I've now done is I've created a secondary non-volatile memory configuration. This is the one I'm currently running on. I can then select this. I can select this. Do a refresh. So I'm now operating on this. So I can now make multiple changes, and if for some reason I have made a mistake, what I can do is I can then always revert back to this functional configuration. So lots of neat benefits on that, and capabilities. So looking back at my system, let me do a quick refresh here to see what we have. I've cleared out this. The last thing looks to be the password still needs to be changed. So user management, what we're going to do is we're going to go ahead and change the default private, and we're going to call it, I'm going to call this Hirschman. Make sure I type it correctly. Configuration for current logged in user will be changed. This performs an automatic logout. Yes, I am okay with that. And we're then going to log back in, admin Hirschman. Let's make sure I didn't fat finger anything. Yes, and I am back in the switch. Let me look at basic settings, system, and alarm counter still shows 1. Default password settings unchanged. And it's probably because of the fact that this guest is, we'll call guest G-U-E-S-T, we'll call guest guest. This is the user, and we're going to go ahead and enable it. It has the wrong length. We'll call this guest 123. That should make it long enough. And do a refresh here, go to here, we'll do a refresh here, and we now have cleared the security status. Again, last thing we want to do is we want to make sure that we then save this configuration so that it will survive a power cycle. So this has been a very quick walkthrough. I've done a change of password. I've named up. I can name the ports real quick. Let me go back into the switch. Under ports, what I can do is, again, best practices would dictate that I name the ports. This is my ring port, going to ring to building 4, and this could be ring to building 2, assuming that the switch is in building 3. So I would then also name all of the PLCs, the I/O, and best cabling practices would then too dictate that one also label the respective cables. From here I can also signal a individual port. That individual port, that port is currently blinking. Not sure why there was an alert, but that port was blinking. And the last thing that I wanted to do is I wanted to go ahead and save these or export these configurations. So what we can then do is we can then take a USB flash drive. We can then save the configuration to a sorry, not a USB flash drive, an SD card. I can then also save that configuration to an SD card for remote storage. If I save the configuration to an SD card and then remove it, I can then put the switch back to factory default, or get a brand new switch off the shelf with no configuration, insert the SD card, and during power up, that switch will clone itself to the previous switch. There's also a way to include the firmware either upgrade or downgrade fully automatically. Reference the manual for additional information. So I hope this has been useful and beneficial. If you have any questions, feel free to reach out to someone on the Hirschman team. Thank you for watching this video. Have a great day.